Okay. Can you guys see that?
Yeah.
Yeah, okay. So today what's going to happen is we're going to look at basically what color light different elements give off. And what we're going to do is I'm going to put different elements on the end of these Q-tips here, and we're going to burn them, and we're kind of going to see what happens and what color light they give off. Can someone tell me why things give off light when they're burned in this case?
Because light goes through the electrons and reflect photons.
Not quite reflect. So basically this fire is giving energy to electrons, right? So those electrons get bumped up to an excited state. What happens when electrons go from an excited state to the ground state? What happens if we go from that high state down to the low state, or a high energy level to a low energy level?
They emit photons.
Yeah, they're going to emit a photon, and based on the element that it is, or what element we have, we're going to emit different photons, and each photon corresponds with the color. So the first one we're going to do is potassium. So go ahead and find potassium on that sheet. It's K. And we're going to see what color potassium burns. Okay. Do you guys see that?
Yeah.
Pretty cool, right? So what color would you say potassium is whenever it burns?
Purple.
Yeah, it's like a nice purple color. Why is it purple again? What's physically happening?
The flame is physically turning purple.
But why?
I don't know.
Why? What's happening to the electrons?
It's going to an excited state and then dropping to the ground state.
Yeah, the flame is exciting those electrons to an excited state. So they're all the way up here. They're very excited. They're in that excited state. They have lots of energy. But remember, electrons don't like to have lots of energy. So they want to drop back down to the ground state. In order to do that, though, we have to shed off some of that energy. We have to get rid of that energy. Because remember, each energy level says you have to have this exact amount of energy. Otherwise, you can't hang out here. So they have to get rid of energy. And in this case, they throw off a single photon. Because a photon, we also learned, is energy. Photon is a particle of light, and it's basically just an energy packet. So we throw off that photon, and it's always going to be the same color photon when we go from that top energy level to our ground energy level. And in this case, the color that corresponds with that photon is this nice little purpley color. Pretty cool, right? Which one do you want to do next? Someone pick one. Barium? Okay. Oh, that's a lot of barium on there. Whoa. Can you guys see that color kind of, or is it too bright?
It's too bright. It just looks like normal fire.
It looks like orange.
So it's not quite.
Like orange and yellow, or like.
So in this case, here, let's see if I can do it. No. Look at the very tip of the flame. For like, it has that, do you see how it has that bright yellow for a second?
Yeah.
In this case, it's going to be that bright yellow. If you could see it here, the whole flame actually turns like a yellow color. But yeah, it looks like it's a bit too bright. But it turns out a cool yellow. Once again, somebody new, tell me what's happening. Why is it turning yellow?
Wait, which element is this?
This is barium.
And
Why is it turning yellow?
The electrons are getting excited and then they drop back down.
Exactly.
To do that, they have to release photons.
Exactly. Why does barium change a different color from what was the other one we just did? Potassium. Why are they different? Why don't they both give off the same color?
They have a different number of electrons.
So they have a different number of electrons, and what does that mean about their energy levels? Are they transitioning between the same energy levels?
No.
No, in this case, they're at different energy levels, and even the energy levels within the atoms are slightly different. They're still those discrete values, but they're going to be slightly different based on the atom. And because of that, different atoms give off different colors of light. What's the next one we want to do? One of the Caitlins. Which one do you want to do?
Calcium.
Calcium. Let's see. Here's the calcium. Calcium looks weird. Let's get some good calcium crystals on there. So this one is the calcium. Come on. Okay. One second, having some trouble getting the calcium on there. So in this case, is the flame really changing color?
No.
So what can we say? What color is it burning? Oh, wait.
Blue.
Do you guys see that?
A tiny spark of orange.
It's like an orange or almost like an orangey red, right? There we go. Now the calcium's burning. So the calcium burns that cool, that orangey red kind of color. Almost caught my little Q-tip on fire there. Let's see, what do we want to do next?
Can we do unknown one?
Can't do the unknown until we have all the other ones done. Because yeah, for the unknown, you have to
Lithium.
lithium. For the unknown, what I'm going to want you to do is I'm going to have you predict what you think it is. Okay, lithium. Here we go. Good old lithium. Let's see. Ooh, that's a cool.
Pink.
It's that pink, magenta almost. Come on, give us some more. There we go. I don't know if you guys can hear that, but it's like totally sizzling over here. Pretty cool, right? I thought about having you guys do this at home because I thought, wouldn't that be kind of fun? But oh boy. We ended up deciding that would probably be not a good idea. Oh. Woo. Starting to smoke up over here. What do we want to do next?
Wait, was lithium pink?
Yeah, it was that pink magenta E color. Let's see, looks like we have, which one?
Copper.
Oh, copper is one of my favorites. We might just do copper twice just for the fun of it. Copper's a cool one. Let's
How
see.
come?
Look at it.
Oh yeah, it's cool. Green.
Do any of you guys watch Game of Thrones? No one? It kind of looks like that wildfire stuff, you know, when they burn down the city. Isn't that a
Would you
cool...
say that's
What?
Would you say that's like a teal color, or is it like a light blue?
It's more of like a green.
Okay.
Yeah, it's definitely closer to like that teal green color than it is the blue. You can see it better. Let's see if I kind of hold it off. Oh no, I think, oh, there we go. Yeah, whenever you try and look at the color, try and look, it's easier to see like if you look at the tip up there to see what the color is kind of. I'm really glad I soaked these Q-tips so that they're not catching on fire. Oh, which one do we want to do next?
Sodium.
Sodium. Oh, I love sodium.
What was the last element?
We just did copper. I think it's in your packet. I think it's called copper 2. The last one in the first column. Yeah, not calcium. Sodium. I love sodium. Sodium is a big ingredient in salt, and I love salt. I could eat salt all day. Let's see. Ooh. Isn't that cool? What color would you say that is?
It looks orange from my
Orange.
perspective.
Yeah, it's totally orange. So in this case, the camera's not lying to you. It is actually a nice, solid orange flame. Actually, so if you see the very tip of it in the camera, that's actually what the entire flame looks like.
That one looks more powerful than the others. Looks like it's bigger almost like.
It is, I think. I think I put a lot of sodium on this one.
Oh, okay.
It's all bubbling up. Oh, I could just do this all day, couldn't you? Whenever I was in chemistry back in the day at Rockwood Summit, we did this or a similar lab. It wasn't exactly the same, but we couldn't get any of the things to burn. So what my teacher did is he put it all in like solutions that were flammable, and he would dump them out on his table because he had a fireproof table, and he would just turn off the lights and light the table on fire. And you could see it, and he did it with copper, and the whole table was just like flaming green. Let's see, I think we only have one left, right? Other than the two unknowns. Our last one's strontium, I
Yep.
believe.
And the unknowns.
And the unknown. Well, the unknowns are fun. I like those. That's when you have to use science to determine what it is. Okay, so I dip some strontium in. Ooh. I don't know if you can see this one as well as I can, but it's very similar to the sodium one that we just did, but it's a little more red. It's a bit of of a darker orange. I told you this would be an exciting class period. Okay, so that's the last one I have before the unknowns. Is there any one that somebody wanted to see again?
Let's see copper again, just so you can have some fun.
Yes. A plus for Kyle. Oh, copper. Oh, it's just so cool. I feel like I'm in Game of Thrones and I'm like sitting on top of the Iron Throne and they're like, burn them all. And they burn down all the buildings with the people in the green flame. I don't think I would actually do that though. Okay, so now it's time for the best part. For the unknowns, I'm gonna randomly pick ones. Two of the ones that we have up here. And what I want you to do is I'm gonna burn them. I'm not gonna tell you what it is. I want you to write down what color flame it is, and then I want you to try to determine what the unknown is. So for unknown 1, I'm gonna put that one in first. This is unknown 1.
It looks kind of reddish pink.
Lithium.
Don't yell it out.
Well, where do I put that?
It's one of the questions below, or it's just like, what metal ion do you think unknown 1 represents and why? Yes, but this one is lithium. Why is it lithium?
Because he said
Because it's pink.
Yeah, it has that pink red flame on it. We can tell it's lithium. I feel like we should do an unknown 3 one because you just ruined all the fun. What if one of your unknowns is copper? Wouldn't that be funny? Oh, it smells horrible. Okay, unknown 2. Don't shout it out this one. This one, whenever you decide what it is, put it in the chat. But do a private chat. Here, I'll get another one. I like what I'm seeing so far, though. Why is it potassium? How do we know that this is potassium?
It's turning purple. That's why.
Yeah, it's turning purple. And we know that whenever it burns that purple, out of the ones that we looked at, we know that that is potassium. Now, just for funsies, because you know this is fun, we're gonna do one more unknown. You don't have to write this one down in your lab though. This one we're gonna do for fun. I don't know. Someone pick a number 1 through 5.
4.
17.
3.
I'm gonna go with 4 because that's the first number I heard. Last time I checked, 17 is not in between 1 and 5 though. Okay, so when you get this one, go ahead and put it in the chat, a private chat. In case you can't see this one, it's yellowy. Yeah, so in this case, this one's sodium. I know this one's kind of hard to tell because of the camera. I have one more, and you better all get this one, or else I'll be very disappointed. I might even cry. For this one, I want everyone to unmute your mic really quick.
All right.
When I count to 3 after I burn it, I want you all to shout out what it is. 1,
It's copper.
2, Kyle!
That wasn't me.
Copper.
That was
Copper.
yeah.
Copper.
I swear that was not me.
Who
Copper.
yelled it out?
I got it. It was
I
copper.
swear it was not me.
Parker.
Copper.
It said Oscar. It said Oscar something when the screen
Oh, it
popped
was
up.
Oscar.
Copper.
No, it wasn't.
I don't know who it was. Oh, well. Okay, let's see. We got to turn this off now.
It wasn't me.
I knew it was copper before you did it.
I could see the green tip.
Okay, turn that off. Unplug this. Let's go find the light switch. Okay, so while I'm turning the lights on, go ahead and answer the 3, I think there's 3 questions on there, 3 or 4 questions. Go ahead and answer those questions to the best of your ability and then submit the lab guide. Why are the lights turning? Oh, I hate the lights in this place sometimes. Now. Okay, once you turn in the lab guide, go ahead and go back to that quantum model assignment, and there's a link to a Google form that I would like you to fill out for that one. Does anyone have any questions on the lab guide? What about number 3? What metal do you think we would use to make a red firework?
Strontium.
Yeah, we could use strontium for that. Why? Why is strontium red? Parker, why is strontium red?
I don't know. It just turns red.
But what causes it to give off a red color? Like, why does it give off any color?
Because they jump to a higher energy level.
So not when they jump to the higher energy level, but when they jump from the high to the low. So we only give off
Emit
a photon when we go from
photons.
high to low energy levels.
What?
What? Did someone say something?
What?
Wait, does the
Read it.
What about it?
The message. Read it.
Okay. What about it?
Are you one of those friends that thinks they don't have to do the
Kyle, what was your question?
I don't so shoot, what was I gonna say again? I just got a little distracted there. So when you're going from high, or does the color matter on how high it was or how low it is? Like after it goes.
So it matters on what the jump is. So you don't like have to necessarily know, but like if you jump from a very high energy level to a very low energy level, that means you have a very large frequency, a very large energy change. And that means you have a very high energy photon, which means a high frequency photon. That's really all you need to know. And frequency and wavelength correspond to color, but you don't necessarily need to know like, oh, red is this wavelength or anything like that. But yeah, the color is determined based off what the difference in energy is between the jump.
Okay.
Okay, do you want to work in groups or do you want to just work on your own?
Groups.
Groups. I like it. Should I just randomly put you in groups or do you want to choose?
Let's choose.
Let's choose. Okay. I had a feeling you would say that. Okay, I'm opening groups, create the rooms. Okay. Let's see. Stella and Jayla want to be in a room together. Does anybody else want to be in a room?
Can I chill with Peyton?
Kyle, was that you that said Peyton?
Yeah, Peyton Andrews.
Can you put me and Jackson in a room, please?
Yes. Okay, I think I got everyone in the room that they wanted to be in.
Could I be in a room with Tommy Ferguson?
Yeah.
Can I be with Summer and Jesse?
Yes, you can. Let me make sure I know what room they're in. Okay. Yes, you're good. Anybody else?